Okay, let's talk about creating a mortgage survey. So you've been working on the cabin project here recently, and what we're going to be doing with that cabin project is situating it on a property, and in this case, utilizing it for a mortgage survey purpose. And what a mortgage survey is there are times where a person wants to buy a piece of property and they get a loan from a lender. The lender may send a survey team out to the site to take record of what the property, where the property lines are, where any utilities may be, where any structures may be existing on the property, trees, sheds, any building lines, or various features, whatever the existing conditions are. And then they keep that drawing as a record to accompany the closing loan documents. So we have quite a few things here on this example of this civil drawing. And so let's mention some of them in detail. Number one, we have the drawing itself. So the outer line work here, represented by the continuous line type, that is the property line. And we're going to be talking about how they're annotated in a second. But within the property, we have the house footprint. The footprint would mean the outline of the house. And so it's represented with just some basic dimensions, the length and width of some of the walls. But the house, really important here, needs to be tied down, as the terminology is to add dimensions from two different corners of the house to the property line so that you could know where exactly that house is in relation to the property. Another thing that's listed here is a building line. These dashed lines represent a limit where you couldn't place the house between the building line and the property line. So there are restrictions for building placement or permanent structure placement from usually the front or the side of properties. And so there may be other restrictions too, but in this example, this represents one that's very common. And usually building lines are measured from the front property line or where the street access is adjacent to that property line. Another thing that's listed on the plan are maybe some notes from the surveyor. So they may list what's called a legal description. So you may have a street address as well, but a legal description is another type of address where in a subdivision there may be 20 lots or 100 lots. So they may also be divided up into something called blocks. So a block might be a collection of 10 lots or 20 lots. So you may have this particular property be lot 2 out of block 5, for example, from some subdivision name. And so the surveyor may also put a statement. It can be very short, it can be very lengthy, indicating certain aspects about the property. Such as this is the correct location. I do certify that what is represented here in the drawing is what's represented on the ground. It's been verified. So those are a few examples of what statements a surveyor may make on this drawing. Also as a legend, so there may be different symbols represented in a legend, but in this case, something that's very common is to show what are called iron stakes. So usually at the property corners, there would be some representation of the surveyor had found in the ground an iron stake that represented that particular property corner. So some of them are found, and if there are none found, but on record there should be, they may be set or reset. Or if you're proposing new subdivision divisions of a property, then the interior lots would have a bunch of iron stakes that would be set in the ground. Typically, a civil drawing is represented with a scale. Of course, the picture of the drawing has to be reduced, can be actual size, or you need a really large sheet of paper. So a scale is represented in inch, or 1 inch equals so many feet. So usually what best works out for largest display on a certain size sheet of paper determines the scale. So generally whatever can fit on the size piece of paper you're showing it is a scale that you choose. So you learn more about this in your next level course, setting scales for drawings and whatnot. So let's go to the next slide. We have some information to talk about, mostly relating to initially drawing the property boundary. That's the thing that we're going to draw first in this exercise. So the property boundary is going to be annotated with something called bearing and distance. The bearing represents the angle of that property line relative to north. And the distance is usually measured in feet, so whatever that distance is. So this is a typical civil drawing, and there's so many different types of civil drawings, but just to get you introduced to one type, we're going to focus on drawing property boundary with the bearing and distance annotations and the structure located. Before we understand what bearings are, let's review what we know about polar coordinates in AutoCAD. So you've been using AutoCAD this semester to draw your objects based on distance and angle. So you may use a variety of different methods. You may use, in this case, polar coordinates, which means if you start at a certain point of beginning and you want to draw a line to a certain distance, you got to also tell the program at what angle you want that line to be drawn. So angles in polar coordinates are measured by default where 0 is to the right and 90 degrees is vertical, and 180 is over to the left, 270 is straight down, and 360 is the same as 0. So the angle of measurement value is measured from 0 in a counterclockwise direction. So this is a typical polar coordinate angular measurement. So this we're familiar with in AutoCAD. But let's look at how bearing angles are notated or calculated. So in this slide, look to the east or look to the right. This no longer says 0, it says 90. But look at up top, it no longer says 90, it says 0. So it appears as those two numbers got switched. But if you look over to the left, it also says 90 degrees. So in polar coordinates, that would have been 180. And down on the bottom, it says south is 0 degrees. So this is really different. So now we have two 90-degree values and two 0-degree values. This is what is one of the things that are noticeably different about bearing angles than polar angle measurements. So in our next slide, what the deal is in a full 360-degree circle, bearing angles are divided up into what are called quadrants. So you take that 360 degrees and you divide it by 4, which gives you a result of 90 degrees for each quadrant. That's why there's 2 zeros and 2 90s, because the maximum degree for any bearing would be 90 degrees. So the quadrant in the upper right corner is called the northeast quadrant, or quadrant number 1. Quadrant number 2 is the southeast corner. Quadrant 3 is the southwest corner, and quadrant 4 is the northwest corner. So we can see the difference now building with bearings versus polar. Now, what if we were to draw a line, a distance, say a property line? So how would that be measured? Well, one thing that's noticeably different is this 30-degree angle measurement is not coming from this line that's horizontal, where it was in the polar coordinates or the polar angles. Typically what happens is with bearings you have two directions. You have either a north and a south to start off, and then you would have an east or a west to finish the direction. So for example, this red line, if we started by clicking at this center point of beginning and we wanted to draw a line in this angle, it's illustrated here or noted that it's a north direction 30 degrees value angle at a west direction. So there's two directions, a north and a west. So that puts this line drawn in a northwest quadrant. And the angle is measured from the north vertical line, not the south. And the reason is if this red line or whatever we're proposing to draw is above the east-west angles here of 90, then that puts it in one of these top two quadrants. So you measure your angle from whatever that top quadrant is and whichever side it's leaning towards. So in this case, it's leaning towards the west from a north angle. So it's at 30 degrees measured from this. If it was measured from this west line, the angle back clockwise, that would be an incorrect correct representation of a bearing, because bearings are only measured from the north going to one side or another, or they're only measured from the south going to one side or another, east or west. So in this case down here, it's in a southeast quadrant. So if we begin by clicking in the center to start the line command and we draw out this way, we could enter in values to say, okay, I want to go in the south direction 75 degrees from south, but I want to head east in the south direction. So that 75 degrees is in the southeast quadrant. So that's how a bearing would be represented. A degree in a bearing angle would be represented. There's a maximum of 90 degrees in any degrees of a bearing. So let's look at this. We have bearings. In order to get more accuracy, you could divide that up into smaller units. So a degree is also could be divided into minutes. There are 60 minutes or 60 parts of a degree, and that is represented by a minute. The minute is represented by a single quote. So you can see if we added more precision to this angle, it's north 30 degrees, 15 minutes. And then we have a 22 double quote. So that means seconds. So a second is a division of a minute. So there are 60 seconds in a minute. So there's 60 seconds in a minute. There are 60 minutes in a degree, and the maximum degree angle is 90. So these more precision angles, bearing angles, are showing degrees, minutes, and seconds. So if this was to be 75 degrees, 8 minutes, and instead of 11, if this was 59 seconds, and if it were to add one more second, that 59 would turn to 0, and you'd carry the 1, and that would be 9 minutes. So the most minutes and seconds that you can have would visually be represented as a 59, and then once you reach 60, it's carried over to the next unit. Okay, so here's an example for you to get out your pencil on paper. Hopefully you have this printed out so that you can estimate where you think the bearing angle would be represented within this compass. So in this first example in the upper left, where would you draw, or how would you draw a line that is a bearing angle of north 60 degrees east? So we're just going to use degrees and not worry about the minutes and seconds, because we're just going to estimate this visually wherever you think that would be. So I'll give you 5 seconds to draw in the north 60 degrees east. Okay, so did you come up with a line that is representative, something kind of like this? Well, the reason is because that north is measured from the northeast quadrant, and the angle 60 would be measured from the north. So that's going to be your 60 degrees right there. Okay, you would not measure up from this horizontal line your angle. Remember, it's always measured from either north or south. So let's look at this upper right one, and let's take a few seconds to draw in south 60 degrees west in this compass, beginning from the center. Okay, so you should have started at the center and then drawn a line something similar to this angle. Just estimating. So the southwest, you're in the southwest quadrant, and that south angle is measured from the south line. So here's your 60-degree angle. Notice these two lines are basically the same angle. So they're the same degree value, 60 and 60, but because northeast and southwest are switched, the line is the same, and they're parallel, but it depends on where you start from. So we started from the same spot, which is there and there, but because the directions were flipped, then they go in opposite directions, but still remaining parallel. Now what this means is, what if our point of origin was here? Here's a little compass. Now you can see this line is a north 60 degrees. If we were to start from this cross right here and draw that way, so now we are going in a northeast direction again. So the deal is your lines will be parallel as long as both directions, north and east, would be switched. Both letters. For example, if we only said southeast instead of southwest, then what we would have is a line that's like this, southeast. And now you can see this line and this line are no longer parallel. So the rule is that if you have, it depends on what end you're measuring your line or drawing your line, then the directions flip, both of them, the beginning and the end. And the first letter can only be a north or a south. The second letter direction can only be an east or a west. You can't switch to where the first letter is east or west and the second is north or south. No, it always first has to be a north or south, and the second direction has to be east or west. Okay, let's look at the next one, bottom left. So this is south 20 degrees east. Go ahead and draw in where you would think is going to be your line. Okay, southeast 20 or south 20 degrees east. You should get something about like this. And the 20 degrees is measured from the south line. You might have been, kind of hesitating and thinking that you would get 20 degrees maybe this way, but that would be incorrect. Not that. Okay, let's try the bottom right. North 15 degrees west. Start from the center and draw in the line. Okay, so from north 15 degrees west, something kind of like this, where our angle measurement is measured from that north line. And there you go. So that's how you interpret and represent bearing angles on a direction compass. So let's go to the next slide. Here's a little bit of an overview of your drawing task that you're going to do. You're going to draw that mortgage survey that we previewed a few seconds ago. So there on the S drive, on the shared directory, you got the site plan prototype drawing that you can access. So just open that and save it to your U drive, your home folder, and create these layers with these names. There may be a few layers in there already, but pay attention to the colors. Make sure it actually says white, it actually says yellow, or it actually says 255. It actually says green or magenta. Because some of those colors may look green, but they're not green. They'll be a number. So make sure when you choose your colors that you get the same results here in the color column. Also pay attention to your line types. So there's a hidden, there's a phantom 2. So you'll just be aware of those settings. Now your line type scale, the command line, you'll set that to 50 so that you can display certain lines that'll be dashed or hidden line types. In your units, you're going to need to set your unit value for the lane type. Civil engineering drawings are usually represented by decimals. So that'd be feet whole numbers and decimals of feet instead of inches. So you'll have like 2.5 feet or 20.9 feet or 20.95 feet. So it's in decimals of feet is what civil drawings are usually represented as. The angle, in order to for AutoCAD to understand that you want to give it a bearing, we have to change the angle type to surveyor's units. And then you can use your precision to represent degrees, minutes, and seconds. And anything that would be inserted into this drawing should be inserted as feet. So it will be scaled to feet units of measurement. Then you want to turn on your dynamic input so that when you draw your property line, you'll enter in your information. I'll show you how to enter it. And then you'll be sure to not add an apostrophe when you're typing in the length of your property lines. But you would add and here's an example, you would add the apostrophe for minutes. And remember, in this case, apostrophe means minutes, and the quote means seconds. So you would do that. On the next slide, once you get your property boundary drawn, you'll offset your building lines, and then you will draw your house off to the side. It's kind of easy to do that. And then this back property line, you're going to offset that, and then you're going to use the align command. Your instructor will show you how to use the align command to um, move and rotate the house to align with that offset line. Then you'll erase the offset line. And then you'll use the dimensions that are set up in this drawing to annotate your bearing and your distance. You just have to type in the bearing because the software is just going to give you the distance value. Then you'll set the survey arrows dimension style current and dimension your building offset lines and your house offset lines. And that's on your check print, which looks like this. You should have a copy of this, or see if your instructor will give you access to it. Then at the bottom, there is what's called a layout tab. You can't see it here in this illustration, but you'll be able to see that in your CAD file. So you have a model tab and a layout tab. So on your layout tab, you'll already see this setup, the border and title block with the notes in there, and you should be able to see your site appear within the window. And again, you'll learn more about how to set up layout tabs in future CAD classes. You should be familiar with your page setup process already. So you would choose your room number. We're going to use the civil plot style. So you should be able to find that in your list of available plot styles. And what this is it takes those colors that you assign to your layers, and those colors determine how bold or how thin the lines are printed. So in your layer manager, you have these colors assigned to certain layer names. And it's very important to choose these exact colors, because an industry standard practice is that an engineering firm would use certain colors to determine how bold a line would print. For example, the property line is magenta. So a magenta color, or the magenta color, would be assigned a bold line weight. So even though it says default here, which looks thin, the result by using that civil plot style would make magenta colored objects really bold. Whereas a building line would be a thin line weight. So many civil firms may choose a certain color or assign a color to produce a thin line when it's printed. So that's what we'd have here, is that we'd have a bold property line and a thin building line. And it's just one of those things, industry practices, that happens in the civil world at least. So your paper size is 11 by 17, and then you should be able to click OK and produce a printed drawing. Always check your work before you turn it in for a grade. But what I want to do to get you started is to show you how to input your property lines, and then from there you should be okay to continue on your own. So because this is a new way to input data, that's what I want to show. Okay?